Hello students, we were doing miscellaneous examples. Okay, so question 14 is given that x plus iy is equal to a plus ib upon a minus ib. We have to prove that x square plus y square is equal to 1. Okay, so how we are going to get x square plus y square? It is x plus iy into x minus iy, right? So first you have to find conjugate of this number. So a plus ib, a minus ib. So multiplying by so this is a plus ib the whole square, a square plus 2 abi plus ib square. So b square I square upon a square minus bi square. Bi minus b square upon a square plus b square. So this is a square minus b square plus 2abi upon a square plus b square. Okay. Conjugate of this will be with a negative sign here, right? X minus iy will be a square minus b square minus 2abi upon a square plus b square. Now we have to multiply this x plus iy and x minus iy. Okay. So that will get x square plus y square. So this is a square minus b square upon a square plus b square plus 2abi upon a square plus b square into a square minus b square upon a square plus b square minus 2abi upon a square plus b square. Now this is of the form a plus b, a minus b. So a square minus b square. A square is a square plus b square minus b square square I square. So it will be plus 1. Okay. So squaring this will get a square minus b square. The whole square will be a raised to 4 minus 2a square b square plus b raised to 4. And this is plus 4a square b square upon a square plus b square the whole square. Okay. So this is 2a square b square minus 2 plus 4. So it is 2a square b square. So I will remove this. And the thing which remains is 2a square plus b square. And this is nothing but a square plus b square the whole square. So it is equal to 1. Okay. Question 15. Find real theta such that 3 plus 2i sin theta upon 1 minus 2i sin theta is purely real. So we have to find value of theta. First you have to write this in the form a plus ib. So multiply by its conjugate. So multiplying you will get 3 plus 2i, 3 to the 6 plus 2i sin theta plus 4 I square sin square theta. 4 I square sin square theta plus 4 sin square theta. Okay. So this is 3 plus 8i sin theta minus 4 sin square theta. This part is imaginary, so we'll split it. So it will be 3 minus 4 sin square theta upon 1 plus 4 sin square theta plus 8i sin theta upon 1 plus 4 sin square theta. Okay, this is imaginary part. So we have to show that it is purely real. So this for theta this should come real. So for this should be real means this should be 0, right? Because when you take any other number, I is there. So we have to remove this I. Okay. So this part should be equal to 0. So if this is equal to 0, then our sin theta is 0, right? So which value of theta it is 0? 0 degree. Okay. And this is for a specific value. We want in general. So for pi also it is 0, right? So we can take for theta n pi. Okay. Integral multiple of pi, where n is integer. Okay. Next one, question 16. Convert the complex number 1 upon cos pi by 3 plus I sin pi by 3. Okay. So first you have to convert this into polar form. So first you write values of cos pi by 3 and sin pi by 3. So this is 60 degree, right? So cos 60 is half and this is root 3 by 2 I. Okay. Now converting this to a plus ib form. So multiplying by its conjugate. Okay. You can take this 2 in the numerator, that is the denominators are same, right? So you can write this as I'll remove this. Okay. So 2 will come here. Okay, 2 is outside. Multiplying this, you will get I minus root 3i square minus 1 plus root 3i upon 1 plus 3. Okay, so this is I square, means this becomes plus, and 1 root 3i. Okay, 2 I will take inside, so it will be 2 root 3 minus 2 plus, you can cut this. This becomes 4, na? So this is root 3 minus 1 plus root 3 plus 1 I upon 2. Okay, so this is your z. Now you have to find mod z, okay, because we are finding polar form. So r, value of r. Squaring, you will get root 3 minus 1 the whole square plus root 3 plus 1 the whole square, and 2 square is 4. Okay. So you can take out half. Inside it is 3 minus 2 root 3 plus 1 plus 3 plus 2 root 3 plus 1. Okay. This and this gets cancelled. You will get 3 plus 3, 6, 8. So it can be written as 4 into 2. So 2 root 2. So root 2 is the answer for Z or Z. Okay. Now finding cos theta. Write cos theta and sin theta. Okay. Cos theta, it is root 3 minus 1 upon 2 root 2, and sin theta y by r plus 1. This is upon 2 root. Okay. Now we have to find theta. Now the problem here is they have given it in the complex form. Okay, very complicated form. So there are two methods which you can use. One is writing tan theta. Tan theta is what? Sine upon cos. Okay, sine upon cos means first you'll get root 3 plus 1, and this 2 root 2 gets cancelled. So this is the answer. Okay. So we have to find, first you have to write this in the form tan A plus tan B upon 1 minus tan A into tan B. Okay, so here it is root 3 plus 1. We want here 1, right? So divide by root 3, both numerator and denominator. Okay. So this will be 1 plus 1 upon root 3 upon 1 minus 1 upon root 3. Okay. So using tan A, so this is tan A plus tan B, 1 minus tan A into tan B. Tan A is 1, so our the theta is pi by 4. Okay. Tan pi by 4 plus this is tan 30. So tan pi by 6. 1 minus tan pi by 4 into tan pi by 6. Okay. So we got the values, that is pi by 4 and pi by 6. This is the theta. Okay. This is tan pi by 4 plus pi by 6. This is the theta. Other way to find this is by using only cos theta or sin theta. Okay. So if you use cos theta, we'll write theta as pi by 4 plus pi by 6. So if you use cos theta, it is root 3 minus 1 upon 2 root 2. Okay. So I can write this as root 3 upon 2 root 2 minus 1 upon 2 root 2. We can split this and write it as root 3 by 2 into 1 upon root 2 minus 1 by 2 into 1 upon root 2. Now we know the formula for cos A plus B. Cos A plus B is what? Cos A cos B minus sin A sin B. Okay. So this is cos A and this is cos B. So our value cos A is cos of, this is 30. So pi by 6. This is pi by 4. This is pi by 6 and this is pi by 4. Okay. Here in the textbook this is not explained. Okay. Actually this is very important. Okay. So this way also you can find. So theta is pi by 4 plus pi by 6. So this becomes 6 pi plus 4 pi, 10 pi, 24. So pi pi by 12. Now you can write the polar form. Polar form is what? Z equal to R cos pi pi by 12 plus I sin pi pi by 12. This is the polar. Okay. Let's solve miscellaneous exercise. First question. I raised to 18 plus 1 upon I raised to 25 raised to 3. Okay. First you evaluate the things which are inside the bracket. So this is very easy. I raised to 18 can be written as I square raised to 9 plus 1 upon I raised to 24 into I. Right. Cube. So I square raised to 9. This is minus 1. So it will be minus 1. I raised to 24 can be written as I square raised to 12. So this is minus plus 1 plus I, 1 upon I. Okay. You can cross multiply here and you will get minus I, 1 minus I upon I the whole cube. Okay. So this using A minus B the whole cube, 1 cube, or you can write this as 1 upon I as into I into I. So this is minus I. You can take out minus 1. This is minus 1. So writing will get 1 cube plus 3 a square b plus 3 ab square side cube. Okay. This is minus I. This is minus 3. So 1 minus 3 is minus 2. 3 minus 1 is 2. This becomes 2 minus 2i. Okay, this is the answer. Next we have second one. For any two complex numbers Z1, Z2, you have to prove that real part of is equal to real part of Z1, real part of Z2, imaginary part of Z1, imaginary part of Z2. Okay. So taking Z1 as x1 plus I y1 and Z2 as x2 plus I y2. Okay. So Z1 into Z2 is x1 plus I y1 into x2 plus I y2. Okay. Multiplying, you will get x1 into x2 plus x1 y2 I plus x2 y1 I plus I square x1 y1 y2. Okay. So this is x1 x2 minus y1 y2 plus x1 y2 plus x2 y1 I. Okay. So we have to prove that real part of z1 z2 is equal to real part of z1 real part of z2 minus imaginary part of z1. So this is your real part and this is imaginary, correct? So real part of z1 z2 is this. We'll multiply real part of z1 into z2 and imaginary part of z1 into z2. Okay, real part of z1 is x1, real part of z2 is x2, imaginary part of z1 is y1, this is y, and this is same as real part of z1 into z. Okay, third question. Reduce to the standard form. Okay, so this is given. Okay. So first you cross multiply this to get I minus 2 plus 8i. Multiplying this you will get 1 I this is I. 1 minus 2 minus 1 plus 9i upon this will be plus so 5 minus 3i into 3 minus 4i upon 5 plus I. Okay. So minus 1 into 3 minus 3 plus 4i plus 27i minus 36i square upon 5 5s are 25 plus 5i minus 15i minus 3i square. Okay, so this becomes plus, this also becomes plus. Okay. Minus 3 plus 36 is 33, 31 I, 25 plus 3, 28 minus 10. Okay. So we have to reduce it to the A plus IB form. So this will be a very big number. Okay. You have to just multiply by its conjugate. So I'll not do the calculation. I'll directly write. You can try this on your own. Just you have to multiply and write. Okay. 42. Yeah. This is the last answer.